For tonight's video, I figured I'd talk about three things. First thing I'll talk about, just like my health, how I'm doing with shoulder surgery recovery. Next thing I'm going to talk about are two projects that I have planned for the spring and summertime. And the third element of this video, I have a component to one of these projects sitting out on the table that I got for nothing, and we'll see if we get that going tonight. So first things first, how am I doing? I'm doing okay. You know, just my life has pretty much been either sitting at home or in physical therapy, or sitting at home doing physical therapy exercises. For those of you that don't know, I had a shoulder surgery on my left shoulder for a torn labrum a few months back, and just in the recovery process right now. Let me tell you, the physical therapy has honestly been probably the most painful part about the whole experience. You know, the surgery sucked, you know, that messed up my system, but what they do, they install like anchors and they reattach your labrum. They like tighten everything up. And in physical therapy, you know, you need to get everything loosened up. You need to regain, you know, your full range of motion. This is the arm that had surgery. But it's, let me tell you, it's really painful because you're pretty much tearing through scar tissue and you're just stretching things out. And ugh, I'm not one for opioids. I really try to stay away from them. But, you know, my doctor said, look, if you want to regain your range of motion, you know, your full range of motion with your arm, you got to take the opioids as needed, of course, and you just got to push through the physical therapy exercises. In fact, I know a friend at work who had the same surgery, and he never really pushed through the physical therapy exercises, and like his arm only goes up, you know, this high. As where me, like, I'm at about 170 degrees with the left arm right now, so I'm working on getting to that 180, but it's, you know, at the end of the day, sometimes you just got to take the painkillers to get through the physical therapy exercises to get back to where you want to be in life. So I'm getting there. Don't worry, I'm not addicted to the opioids yet. No, I only take them as needed, but we're slowly getting there, and I'm starting to have a more positive outlook on where I'm ultimately going to be after the surgery. So yeah, that's another reason why I haven't been uploading, is just because I've been dealing with health issues. So aside from that, let's talk about one project that I have planned, and then we'll talk about the other one down here. So a little while back, I found this channel on YouTube. Channel name is From Steel to Wood. And I'm not sure where this gentleman is from. His name's Jonathan. I believe he's up in Canada. He talks with an accent. You know, his English, pretty good, of course, but he definitely has that accent. I think he's from Canada. But anyway, he's a really crafty son of a bitch, let me tell you. He's really good with his hands. I believe he's an engineer by trade. And he's really into processing like his own wood. And he built his own box splitter on a trailer. But the really cool thing about the trailer, and something that really sparked an interest in my mind, on his trailer, he has an articulating jib crane, which a jib crane pretty much has a fixed boom at 90 degrees. But what's interesting about his design is about 3/4 of the way down the boom, there's a knuckle. So he has probably a quarter of the boom that hinges off that knuckle. You'll have to go check out his channel and his videos, From Steel to Wood. In fact, I'll leave a link in the description down below of the specific video that I'm talking about. But he has this articulating jib crane mounted on his trailer with the box splitter on the bottom of the trailer, and he has a winch attached to this jib crane. So from there, he has a winch line that goes down to a set of tongs, and what he does, he cuts up, you know, logs, big chunks of logs in his yard. He takes his trailer with the jib crane over, he goes over to the logs, lowers the winch, attaches the tongs and the winch lift up these big rounds of wood, like up to, he said he's lifted up to 400 pounds with this thing, drops them right in the splitter, splits them, and then he has firewood, which I just love that, because, you know, after this surgery, I've just been really rethinking the way I do things, and I'm trying to limit the stresses on my body. Like, I'm done with just doing stupid lifting heavy loads. Like, I'm just thinking in the long run, and like I gotta start getting smarter and stop working harder. So that really captured my attention, and I'm kind of copying his design. I actually emailed him and I asked him, you know, what are some of the things you would change about your design? And there's a few things he mentioned, so let me show you the draft I have drawn up. It's really similar to his design. To be quite honest, I'm pretty much copying his design. But as for the actual swivel mechanism, I have something a little bit different design for mine. Alright, so here's a quick look at my design, and this was all just free-handed. You know, of course I still have to figure out what size materials and what kind of trailer I'm going to use, but a long time ago, back in high school, I was actually an engineering student, and if you ask me, one of my biggest regrets in life was never finishing my engineering degree. I really wish I pursued that. So kids, if you're listening to this video, pay attention in school and try and get a degree in your chosen field, because I've always been one to say that you don't really need a degree to be successful in life, but at the end of the day, if you get injured, it's something to always fall back on. But here's what I have planned out. So the trailer that I'm thinking about using like a cheap little 4x8 Harbor Freight trailer. The idea behind this trailer is I actually want to be able to tow it behind my little Craftsman lawn tractor. So I want a trailer that's kind of narrow, but I also want it to be able to be towed down the road. Like if I ever want to hook this up to my truck and take this to like Home Depot and lift up, you know, deadlift something that's a couple hundred pounds, you know, I could totally do it with this crane. So we have 4x8 trailer. There's going to be a battery box, and that's going to be one of the weak points of this whole system. You know, there's going to be a winch up here, but the winch is going to be powered by this battery, and the winch is only going to be able to run as long as the battery will allow it to run. So we'll have to think a little bit more about that. But basically, we have a main boom right here, and it's braced up. There's going to be 2 stabilizing brackets, so there's going to be 3 points that support this boom. I'm thinking about using a round piece of pipe, perhaps a 4-inch diameter pipe, something like that. And here's the jib crane. So we have a right angle right here. We have the first part of the boom, and then we have the second part of the boom. And just like Johnathans design, I would like mine to articulate hopefully a little around. If I can get this to articulate 180 degrees, I'd really be happy with that. But why is that important? Why do I want this to articulate at 180 degrees? Well, the reason being is because I can swing this out and I can pick up a log, and then when I swing it back, I can overswing this part of the boom. I can hinge this in. So basically, I can either drop the log, you know, right here in the trailer or right here or anywhere in between. So by having this articulate, it gives me more range of motion as to where I can drop the log on the trailer. And for me, what I'm thinking is I'm going to use this articulating jib crane to pick up logs on the ground. I'm going to put the logs in the trailer, and then I've actually recently gotten an electric log splitter. So I'm going to go over to the log splitter, lift up the logs out of the trailer, drop them directly on the log splitter, and then put them on the stack. So that's kind of my plan, which is a little bit different than Johnathans, because Johnathans trailer has the box splitter right on his trailer, and he also has an alternator hooked up to charge the battery. So I thought that was a pretty creative idea, but I don't think I'm going to go that route. So yeah, there's the articulating jib crane, and here's what I'm kind of thinking about doing for the hinge mechanism. So we're going to have the main boom. You're going to have this supporting piece for the main boom right there, that brace, and then I'm thinking I'm going to have a pin in the top of this main shaft so this boom can rotate 360 degrees, but I also need something down low to support the support member for the boom. So this has kind of been what I've been trying to figure out, like how am I going to design this. And basically what I'm thinking about doing is using a bunch of bearings that I have, and I'm going to cut out a circular piece of metal and drill a bunch of holes for those bearings. And then, you know, that metal is going to be able to be welded on, and I'm going to be able to weld on the support member right here. And on the back side of this round piece of metal that will house or support the bearings will be a winch. So this is the winch right here. So the winch cable is going to go up. There's going to be a pulley on the top of the boom, and this whole mechanism is just going to rotate on the shaft. So we're going to have the winch cable come up over this pulley right here. And here, again, I'm copying Jonathan right here. He has a wraparound pulley right here. So the winch cable wraps around and then goes to this last pulley on the boom. Because there's a wraparound pulley right there where this second part of the jib articulates, that allows you to still utilize the winch, but also to, once again, swivel this part of the jib. So let me take you over to my little mock-up that I made. So here's a little mock-up model that I created, just kind of like, it's not necessarily a proof of concept, but I'm just trying to put together kind of like some rough design here. See, this is what happens when you get off Facebook and social media and you have nothing better to do. You start using your brain and you start creating creative. That's what it's all about. So kids, get off that social media, get out in the garage, start building something. But anyway, here's what I was talking about for the main shaft, I guess. So this is probably going to be like 4-inch pipe, something like that. Probably going to have like a 1-inch dowel coming out the top. This is going to be the main part of the boom, where the jib is going to articulate right here. But this is what I was thinking. I really want this to be able to rotate 360 degrees, because if I am towing this behind the truck, maybe I can utilize this crane by towing the trailer and having this boom rotate 360 degrees and be able to drop something in the back of the truck. I'm going to have to add stabilizers at some point, but this is kind of what I was thinking. I had these bearings. These are 6303 bearings, which I have these bearings. They're just sitting around. So what I'm planning on doing is cutting out a round metal disc, a top piece and a bottom piece. Just cut that out with the plasma cutter. I'm just going to drill holes for each of these bearings. I'm going to put a bolt through the disc, top part of the disc, through the bearing, bottom part of the disc, bolt that down, and that should allow me to weld on this support for the boom. It will allow this to rotate 360 degrees and firmly stay in place, because those bearings will be nice and close to that main shaft of the boom. And also I'm going to be able to weld on a plate on the back of this, you know, off the main boom down to that disc down there, and that'll give me a nice that'll give me a nice area to weld on a plate to mount my winch. And that's another tricky thing that I'm trying to figure out too, because I want to have the winch in an area where I can pull the free spool lever and just be able to take the end of the winch line and just run it free spool, so I don't have to, you know, waste the battery and waste time letting that winch unwind with the remote. So this is just kind of like a little model right here. You guys let me know what you think. You think this is going to work? Is it not going to work? What could I do to improve this design? Let me know in the comments section down below. So once again, I'd like to thank Jonathan from Steel to Wood thus far on all your helpful information. I'm definitely going to be in touch with you as I move along with that project. But there's a project that I want to try and get done before that project, and I want to build a conveyor belt. How's that saying go? The root of all inventions stems from necessity. I don't think that's how it goes, but what I'm trying to say is inventions come from people that have problems and they need a better solution, an easier solution for that problem. So once again, you know, here I am in my debilitated state and I have a problem. I have a hillside and there's a stacked rock retaining wall, and it's really hard to get mulch up there. And if you don't put mulch on top of the hillside, then the weeds pop through, and nobody likes to look at weeds. So the only way in the past, the traditional way in the past to get mulch up the hill has been to take this little goat path, and it's narrow and it's steep, and it's too much wear and tear on my body. Call me what you will, but I'm trying to think smarter and not work harder. So what I want to build approximately a 10 to 15 foot long conveyor belt. And I'm trying to do this kind of on the cheap, because you can go on Craigslist or Kijiji, as Pug1 calls it, and you can find like a 15-foot conveyor belt. But I mean, like a pre-assembled conveyor belt costs, you know, anywhere from $1,000 for kind of like a rundown one to, you know, you're probably looking at up to 10, 15 grand for like a really good conveyor belt. So I'm planning to build my own on the cheap, and I drew up a set of plans right here. And I actually got this motor for free over here. It's a 1/4 horsepower motor, spins at 1750 RPM, and it actually used to be a palm pump motor, 115 volt, and this is the housing that used to be on it. So I ripped off the housing and I went to plug it in and it wouldn't spin, so I started digging into it. Let me just show you what I found. So I love getting stuff for free. But let me tell you, it absolutely stinks when the label is almost completely worn away. This is an Emerson motor, but I couldn't make out the model number. I could barely make out the horsepower, which this is a 1/4 horse, volts, 115 volts. But I really didn't have much information to go on with this motor. All I knew was that when I plugged it in, it hummed. It hummed, and that's about all the information I had. So there's this little cap that sits on the top of the motor, and there's these two wires right here. And those wires go to a capacitor, which I'm not sure if it's a starting capacitor. I think it's a starting capacitor. But here's what I found. Here's the capacitor, which you can clearly see that the capacitor is blown. It is shot. Unfortunately, though, it blew apart in a way that the numbers were not legible. So I really had no idea what size capacitor to put onto this motor. This is going to be probably one of the most important parts of my conveyor belt project. So it has what I suspect to be a bad capacitor, but I know nothing about this motor. I don't know the model number. The only thing I know is I know that it's a 1/4 horse and it is 115 volts. So I spent a lot of research online, and this is how I kind of came to choosing the capacitor that I chose. So 1 horsepower is equivalent to 0.746 kilowatts. So if we go to my calculator here and we take 0.746, which that's 1 horsepower, we have a 1/4 horse here. I'm going to divide that by 4. And that gives us 0.186. Well, 0.187 if we're rounded up in terms of kilowatts. And I found this website online with this chart to help you figure out what size capacitor you're going to need for your motor. So we're going to go to table 1 right here. Table 1 is for low voltage, 110 to 125 volts, which our motor is 115 volts. So we're going to use this chart. The second chart down here is for 220 volt motors. So motor size, the motor size goes by kilowatts. Here we have a 1/4 horsepower motor right here. So there's kind of like capacitor sizes go by this weird shaped U and an F, which I don't know what that stands for. Somebody probably could comment on that in the comment section down below. But basically, I think we're looking for a capacitor between that has a value between 160 to 200. And I didn't find one exactly at that. I have a capacitor that is 145 to 110, which this one is a little bit low. It was just easy to come by. So what we're going to do now is we're going to plug in this capacitor, and we're going to see if this will start up the motor. I wish I had chosen a more appropriately sized capacitor, but we will test this out. Hopefully this will do the trick. So we're going to have the capacitor installed. Motor is clamped down. Moment of truth. All right. All right. I'm pretty happy about that. So at least we know this motor runs. Now, I figure the worst case scenario, because this isn't exactly the perfect size capacitor for this motor according to that chart, worst thing that happens, I would think, is that I burn out this capacitor again, and then I'll have to get a different one better suited for a 1/4 horsepower motor. So here's my first draft for my conveyor design. Now, what I'm thinking about doing is taking probably like, I'm not 100% sure how long I'm going to make this, but I'm thinking I'm going to make this out of wood, probably 2 by 10 by 16 or 2 by 10 by 14, 2 by 10 by 12. Not exactly sure how long I want to make this, but I'm going to try and do this on the cheap. So the main drive wheel, I'm thinking about using like maybe a 4-inch piece of PVC. See, I have that calculation right there. So I'm probably going to use like a 4-inch piece of PVC, and to gain traction on that, I'm going to have some type of flange that bolts onto the shaft, onto the end of the PVC. I'll have an end cap bolted on, something like that. As for the actual traction of the PVC onto the belt, whatever belt material I use, I'm thinking about just stretching out an inner tube and throwing it over that piece of 4-inch PVC. Not 100% sure yet. I got to work out the bugs here, but here's one of the issues I have. This motor spins at 1750 RPM, and that would be way too fast for this system that I'm planning on building. So what I did here is I just kind of went over a quick gear reduction system. Starting off with the motor, we have a 2-inch pulley which goes to a 10-inch pulley, so that's a 5-to-1 reduction. So we reduced that 1750 RPM down to 350, and then I was thinking about doing another 5-to-1 gear reduction system. So we have a 2-inch pulley and that goes to a 10-inch pulley, so therefore slowing down at 350 RPM to 70 RPM. So we have the motor right here, 5-to-1 reduction, 5-to-1 reduction onto the final drive shaft. There's going to be that 4-inch piece of PVC behind this piece of wood. So here's how I figured out how fast this belt is actually going to drive, which I think this is a little bit slow. So we have a 4-inch in diameter piece of PVC pipe. That's going to be our main drive wheel. The circumference of that is 12.75. So the circumference times the RPM equals the surface speed. So we take that circumference of 12.75 inches times 70, which that's our RPM, we get 880 inches per minute. And I did a quick Google search and I converted that to miles per hour, and that comes to 0.83 miles per hour. I think that's a little bit slow. I think I'm going to change some things and I'm going to get that spinning a little bit faster. I don't know. I think I'm going to shoot for like maybe 3 or 4 miles per hour. Not 100% sure, but still have to play around with that. Another thing that I'm trying to figure out too, which I think I kind of have it figured out, is with this whole system, I have to figure out a way to put tension on whatever belt material I decide to use. And this is the tensioning mechanism that I kind of came up with real quick. So again, we have the we'll say it's a 2x10. So I'm planning on cutting out this slot, and in this slot, there's going to be a pillow block. There's going to be a piece of angle right here, and there's going to be threaded rod, or all thread. So basically, that pillow block is going to house a 1/2-inch shaft, which will connect to another 4-inch roller at the top right here. So that's just going to be a free spooling roller. And the way we're going to be able to tension that belt is by tightening up this threaded rod, which that would definitely take some time, but at least we can put tension onto the belt, especially if it's slipping, and if it's tracking improperly, if it's on one side of the conveyor more than the other side, we can adjust the threaded rod on one side more to put more tension on one side, hopefully correcting that mistracking issue. Now my question for you guys, you more engineer inclined, what am I trying to say? The people out there that probably know more than I do about motors and gearing and this and that, I have a 1/4 horsepower motor. I'm probably looking at making a 12-foot conveyor, and it's probably going to climb at about a 35-degree slope. My question is this motor strong enough with the gear reduction to raise probably 20 to 30 pounds of material up this conveyor at a time? That's just the one thing I'm not 100% sure about. I'm sure there's a way to calculate that. If you know how to calculate that, please let me know in the comment section down below, because that would be most helpful. I really have no experience with electric motors and building, systems like this. So my other question is too, this originally was designed to house a propeller. So this is not a keyed shaft. This is a 1/2-inch. This is a 1/2-inch shaft. So I was thinking that, the first pulley I'd use, 2-inch pulley, 1/2-inch bore, put it on here. My question is, how do I transfer the power from the motor to that 2-inch pulley? Do you guys think I should just cut a slot in here and then insert a keyway for that 2-inch pulley? Or is there a better way to go about connecting that pulley onto this 1/2-inch shaft? Because, there's no keyway. There's just kind of this threaded end right here, and I don't think I really want to use that threaded end. I am planning on using belts. I'm not going to use chain. So if something is too much for the motor, or if it's too much load, then hopefully the belt would slip. Of course, I could shut the motor off right away, but I like the idea behind belts that if something does get bound up, the belts would just slip. So that's what I'm planning. Before I really get into building these projects, I mean, it's going to be a little while, you know. Before I get to work on the conveyor project, I'm thinking before that really gets going, it's probably going to be like 2 months. One thing that I do not have completely figured out is how wide of a conveyor am I going to use. Like, I plan to use this conveyor for multiple purposes. I want to be able to use it for putting mulch up on top of the hill. I'd like to be able to use it for topsoil, and I'd also like to be able to use it for firewood. So I'm thinking maybe like a 10-inch conveyor. But another thing that I have to figure out is how do I make that conveyor slope? Do I have 2 rollers going down diagonally? Do I just have a friction surface where the belt just kind of pulls over? Of course, that's going to be harder on the motor, but that's going to be easier to build. You know, maybe just some PVC rails on the side that just flip up the sides of the belt to kind of keep the material centered along the belt. So yeah, still have a few things to figure out. Belt width is definitely one of the big ones, and then the speed of that belt. I'm thinking probably belt width between 8 to 10 inches, but it also depends on what material I'm going to use for the conveyor belt, because let me tell you, conveyor belt material, even used, is incredibly expensive. Like, I'm looking at used conveyor belts right now, and they go anywhere between, like for what I'm looking at doing, at the very least, you're looking at spending $120 for used material. And, you know, if you're looking for brand new, geez, looking in a couple $100, you know. So if you guys have any suggestions on conveyor belt material, I'd like to hear what your suggestions are. Whether I should use a friction plate system or rollers for moving the material up along the conveyor. I'm thinking I'm leaning towards a friction surface. Of course, trying to reduce that friction as much as possible. But the biggest question I have, and I'd really like your input, especially you guys out there that know more about these calculations than I do. 1/4 horsepower motor, geared down, you know, maybe to 100 RPM, maybe 120 RPM is probably what I'm looking at now. Is that motor going to have enough energy to lift, to raise maybe 20 to 30 pounds of material up that conveyor at a time? You know, probably 30-degree angle, maybe 35-degree angle, you know, pretty steep. Is that motor going to do it? I think it will. I'm not 100% sure, but there are a lot of variables. How much I can reduce friction. Yeah, I don't know. Whether it's going to work or not, I think I'm still going to build it. And if that motor proves not to be strong enough, I do have another free motor over there. Unfortunately, it's a 220 volt motor, which I do have a 220 volt plug over here. But, you know, it's just nice having 110 because then you can plug it into any outlet around the house. So it's just much more convenient. But please let me know if you think it's going to work. If not, why? Things you'd improve. And regardless, it's definitely going to be a fun project, and I look forward to building it. So anyway, that's it for tonight's video. My beer's about out now, so I'm going to go inside and cuddle up by the fire. But thanks for watching, and catch you on the next one.